This is the lesson for Mod 7, Lesson 6b, Evaluating Trig Ratios on the Coordinate Plane. The goal today is going to be evaluating trig ratios on the coordinate plane, so we're going to be tying in all the ideas we've done with a little bit of the unit circle, but mostly reference angles or special right triangles, and finding different values on the coordinate plane for trig. So our first step we're going to see is that we're going to end up first sketching the angle on the coordinate plane. We're still using the idea of 0 degrees, 90 degrees, 180 degrees, 270, and 360. So that part hasn't changed. We're going to using also the idea of the quadrant. So in quadrant 1, they're all positive. In quadrant 2, sine is positive. In quadrant 3, tangent's positive, and in quadrant 4, cosine's positive. So we're still going to be using that all Slurpees taste cold, all students take calculus. We're also going to come up the special right triangles. So we want to make sure we definitely remember our ratios for those special right triangles. So the 45, 45, 90, that 1, 1 radical 2, and then the 30, 60, 90, 2, 1, and radical 3. So we're going to see that come up a lot as well. And then for angles today, or degree measurements that do not have reference angles, we're going to use the idea of the unit circle. So if I do have, let's say, 180 degrees, remembering that we have the point -1, 0, and for 270 and all of those. So all of them we can use reference angles with the exception of if it's on an axis, and we might find we use some of the components from our unit circle for that. For our first example, we're finding the sine of 210 degrees. So the first thing we're going to do is go ahead and sketch where that would be on our coordinate plane. So if I go ahead and label everything out, I know I have 0, 90, 180, 270, and 360. I can see that 210 degrees is going to be in quadrant 3. So my first step is just simply sketching it on the coordinate plane. I then see I'm trying to find the sine of 210 degrees. And so sine in this quadrant, if I look at my, the all Slurpees taste cold, or all students take calculus, in quadrant 3, we have tangent as positive, which means that the other two are negative. And so our sine for this is actually going to be a negative value. So our first step, we sketched it, we then found the sine, or if it's going to be positive or negative. And now we're going to go ahead and create a right triangle with this. So I'm going to use a reference angle. So if this is 210, this is 180. If I subtract, I'm going to get 30 degrees. So I have a triangle with a 30-degree angle. All right, so up to this part, this really isn't anything too brand new. We sketched the triangle. I have found a reference angle. I saw that sine is going to be negative in that quadrant. And now I'm going to go ahead and try to find what that actual measurement is. So 30 degrees, I know the hypotenuse, I could treat as a 2. This is a 1, this is a radical 3. And then if I want to find sine, sine is the opposite over the hypotenuse, so I see it's 1 over 2. If I used my unit circle, I would have gotten the very same answer, because remember the unit circle, we talked about how it was in the form of cosine sine, so you could have read that off there as well. The next example, very similar, so I have a tangent of 300 degrees. So I'm going to do the same thing. And so I have here 0, 90, 180, 270, slash 360. 300 degrees is going to end up in quadrant 3, or in quadrant 4. So my first step is just simply sketching where it would fall. We're then going to find, well, what is tangent going to be in that quadrant? So if all Slurpees taste gold, I can see cosine is actually going to be positive, which means tangent and sine would be negative. So I know I'm going to have a negative number. So I'm going to write a little negative sign so I remember. And then I'm going to also try to create a right triangle. And this is 300 degrees. My reference angle, if I go ahead and find what that little angle is, I'm going to get 60 degrees. And so now we're just taking our special right triangle and putting it in there. So our special right triangle, our hypotenuse is 2, the leg next to the 60 is 1, and this is radical 3. So I'm looking for tangent, so that would be opposite over adjacent, so radical 3 over 1. And I have that negative there, so negative root 3 would be the tangent of 300. For the last example, same idea. I'm going to go ahead and sketch this out. I'm looking for 180 degrees. So 180 would be right here. And we're going to find, and this one's asking for secant, but 180 you're going to see doesn't have a reference angle, right? Because it's formed with the x-axis. So if we go ahead and look at that, what we're going to find then is we're actually going to use the unit circle a little bit. So remember the unit circle, when we had our whole circle, it was a radius of 1. So this was the point actually -1, 0. And so remember for the unit circle, we said that cosine of theta sine theta was x and y. So secant that's going to correspond to cosine. So the cosine is again the x value. So -1 would be cosine. So if I flip it, it happens to be the same thing. So secant of 180 is -1. And again, you could have saw that off the unit circle as well. For the next topic, this one's very similar to what we saw with in the previous one. It's just kind of just, again, some of the similar values, but same concept. So they tell us cosine is 1/2. So I know cosine is 1/2. Secant is 2 over 1, which is 2. Tangent is less than 0, so tangent is negative. So now we're going to see, well, if I label this out, what quadrant is, if they're different signs, I know they can't be quadrant 1, negatives quadrant 2, so it's going to end up being quadrant 3. And so we end up doing the same thing as before. So this is our angle, cosines 1 and 2. We could do Pythagorean theorem, but it actually is a special right triangle. We can see that. So we actually, this is the point of this problem, is just kind of recognizing that we don't have to do Pythagorean theorem. It actually ends up being a special right triangle because a hypotenuse of 2 and a leg of 1, you're going to get root 3. And so now we can go, but if we wanted to do Pythagorean theorem, you could have done that, and you would have gotten the same answer of root 3. And so now we can go ahead and fill all of our stuff in. And then in this quadrant, cosine's positive, but we know sine is negative. And we can go ahead and fill all our stuff in. So we'll have root 3 over 2. This would be then 2 over root 3. And then tangent would be root 3 over 1. And this would be 1 over root 3. And then we would just rationalize at the end. So this one's more of kind of like a little bit of a throwback problem. It just, again, if you kind of recognize it was a special right triangle, you didn't necessarily have to do Pythagorean theorem. And then for our last problem, same idea. We're going to go ahead and fill this in. So sine is negative root 2 over 2. Cosecant is going to be the flipped version. It's negative. For this one, they tell you cosine is positive. And so we know that when we sketch this out, it's not going to be quadrant 1 because they're different signs. This one also happens to be quadrant 3. So cosine is positive, and then the other two would be negative. So tangent we know would be negative. And now when we fill this in, we have root 2. This would be a 2. But again, you might recognize that this is a special right triangle. So you can go ahead and do Pythagorean theorem if you want to, but you might recognize that this actually just ends up being a special right triangle. So either one works. I'll do it the same way we've been doing it already, but again, there's faster ways to do the problem if you want to. So I have here root 2. If I wanted to use Pythagorean theorem, I could, but again, there's faster ways to do this problem. All right, so we get this to be root 2, and then you would see cosine is actually going to be root 2 over 2. This one, same thing, 2 over radical 2, and then tangent, root 2 over 2, root 2 over root 2, which is negative 1. The flipped is negative 1, and then you would rationalize this out. Okay, so you might find also, again, if you recognize this was a special right triangle, this actually simplifies a little easier. And that would be your final answer. If you have any questions, please make sure you ask them during T-Bowl time, during class, or you can come to the center. And remember, you do need to complete the You Try problems to receive full points for the notes.